So current electricity. Okay. So current electricity means when the charges are in motion, they are known as current electricity. Now we start with current. The formula for current is what? Current I is equal to what? Q by T. Okay, rate of flow of charges is known as current, and measured in what? Coulomb per second or amperes. Measured in. If you don't write AMP, this is wrong. This is wrong. Write ampere. If you want to write full name, write ampere. This is the way of writing. Do not write AMP. AMP is a different thing. Now, I is equal to Q by T, and current is measured using what? Which meter? Current is measured using, yes.
So what?
Current is measured using which device?
Ammeter.
Ammeter. Very good. And it should be whether it should be connected in series or parallel.
Series.
Very good. We have, it can be represented in this way. Okay, and it should be connected in series. Okay, so we have here milliammeter, microammeter, and nanoammeter. Instead of nanoammeter, we write nanoammeter is nothing but galvanometer. Okay, so this is milliammeter. This is a family. If you have current of magnitude 10 to the power of -3, you will use milliammeter. If the current is of, this chapter is very important for your practical also. In practical, almost 4 practicals, I think. That is VI characteristic of a VI characteristics. Second, meter bridge. Then Wheatstone bridge is not there. Potentiometer is remote, but deflection galvanometer and all this come from the same lesson. So Viva is also, this chapter Viva also will be useful. And this is micro. Micro is 10 to the power of -6, and then nano is 10 to the power of -9. Okay, is that clear? Milli, micro, and nano. Now, next is what we have Ohm's law. What is Ohm's law? What is Ohm's law? If this is the question asked in your Viva, how will you answer it?
Sir, the resistivity is directly proportional to the current flowing in the circuit. Sir, is it
equal to IR?
At constant temperature, you have to mention this at constant. This law was proposed by George Simon Ohm. So he says that at constant temperature, current is directly proportional to potential difference applied. Okay, so V is proportional to I implies V is equal to IR. Okay, what is R here? R is resistance. Okay, what is resistance again? What is the definition of resistance? Opposition to the flow of current. Okay,
Flow of current.
Opposition to the flow of current is said to be resistance. Okay, opposition to the flow of current is said to be resistance, and resistance is measured in what? It is measured in ohms. Okay, it's measured in ohms. Is that clear? Opposition to the flow of current is said to be resistance, and it is measured in ohms. Okay, we can write kilo ohms like this. Kilo ohm means 10 to the power of 3 ohms, like that. Kilo ohms, mega ohms, like that. We can write. Next, after this, we have resistance. Okay, so before going to that, we have to first classify the material. How it is classification of material. So we have conductors. Insulators, then semiconductors, then dielectric material, then the last is what? Superconductors. Can you tell me about this material quickly? What are conductors? Which allow the passage of current. Conductors are the material which allow the passage of current. Okay. Can you give me the example for each? Conductors. Examples.
Conductor silver.
Yeah, we can write.
Copper.
You have to be a little faster because I need to do 3 derivations of drift velocity, which is very, very important. Out of 3 derivations, 1 will definitely come in the exam. So I need to be faster. Okay, tomorrow, so that why I am telling you, because I want to solve some Kirchhoff law problems tomorrow in tomorrow's class. After doing Wheatstone bridge tomorrow I'll be teaching Kirchhoff law. Kirchhoff first and second law, then I will be teaching the Kirchhoff law numericals, which is very, very important. It can be asked as a 3-marker question, or it can be asked as a 5-marker case study, 4-marker case study question also. Anyway, definitely it will come in the exam. So I want to spend some time tomorrow on that. Okay, Kirchhoff law and Wheatstone bridge, that part. Okay, so that today I can finish up. And you have to spontaneously answer, please. Don't just sit quietly there. Can you give me the example for the conductors?
Copper, silver.
Yeah, copper, silver, gold, aluminium. Okay, these are the examples which allow the passage of current. What are insulators?
Which do not
Which
have.
do not allow the
Which do not allow the flow of current and
Very
offer
good.
some resistance.
Which do not allow the passage of current. What about the example for this?
Plastic.
Wood, glass.
Very good. Wood, rubber, plastic. Okay, wood, rubber, and plastic. And what is superconductor then? Semiconductor. Sorry.
It is intermediate between the.
It allows very small amount of current, very small, micro or nano, very small amount of current. Those are semiconductors. What is the example for this? They are silicon and germanium. Silicon and germanium. These are the material. What are dielectric material? Yesterday we discussed about this. What are dielectric material? Yes, please. Yeah, dielectric material means when you place this material in the presence of electric field, the dipoles will align in the direction of the field. The dipoles will align in the direction of the field. Example for this is what? Glass and mica. Okay, mica and glass. This is the example. What are superconductors then? Superconductors are
Conductors which do not have any resistance.
Resistance here. Resistance is 0.
very good. The temperature, if the temperature is very small, means 4 Kelvin, small t is minus 269 degrees centigrade. At that temperature, what happens? The resistance of the material was found to be 0. This special property was found by a scientist known as Kamerlingh Onnes. Okay, for which he got the Nobel Prize. Okay, this is very important property, because of which in biology, if you go to stem cell banking, maybe you might, bio students know about it. It is about stem cell banking, like the cord between, there is a cord between the mother and the baby in the womb. Umbilical cord. Okay, the umbilical cord is at the time of delivery or at the time of birth of the baby. This umbilical cord is thrown away. But actually, if you discuss with the agency, there are some agencies who store this. So if you speak to them, what they do is they tell the doctor to preserve it in they give the box and they store it in that, and immediately it is taken to the agency, where they keep it at minus 176 degrees centigrade. Like generally, if you keep something in the fridge and the freezer, especially like meat or fish, something, it can be stored for a long time. It is only minus 20 or something in the freezer. But at that temperature, the cells will become standstill. And suppose if the baby requires the blood, maybe in future, you can still just tell the agency people, then they will make the blood from the same cells and they will supply it to you within no time. So this is how this is a very important property which is used in stem cell banking in biology. Okay, so I'm not that much aware, because I was doing in biophysics. I knew about this thing. Okay, so so this is about the different types of material. Okay, superconducting is very important property, because now maglev vehicles, okay, magnetic levitated trains in Japan. Okay, this is there again. We study in magnetism chapter. Magnetism chapter we study this 6th chapter, I think. Yeah, 5th or 6th chapter. So magnetic levitated trains. So which is in the bullet train in Japan. This works upon the same principle, superconducting phenomena. So this was started around 50 years back. There is no accident until now, and this is like floating in the air. This train is 4 inches above the track. Okay, and really it is fast, around 500 kilometers per hour. Very close to the speed of the aeroplane. So this is about the superconducting phenomena. Next is about conductivity. First, we'll discuss about the factors affecting the resistance. What are the factors which are affecting the resistance? What are
the material of the of the conductor.
First is what? It depends on the length. Second one, it depends on the area.
Cross section
area. Very good. Third one, it depends on the
temperature.
Very good. Fourth one,
A material of
Nature, very good. Material or nature of the material. Okay. So these are the four properties on which the factors on which the resistance depends. First of all, now go to the length. As the length increases, what happens? Resistance also increases. Is it not? This you studied in grade 10 online classes. Now, so what about area? As the area increases, resistance increases or decreases?
Increases.
it's inversely proportional.
It decreases as the area increases, resistance decreases. I will give the reason for that. This can be asked as a reasoning, as assertion reasoning question also. Don't think it is a very simple thing, but still they can ask in the assertion reasoning. What happened, in grade when I will send the paper also with me, the last year's question paper. Okay, last year's question paper, I will send it to you with a marking scheme. It's completely 40 marks objective paper. Okay, and I will check with the examination in the room. Suppose if I have the last year's board paper also, second term paper also, I'll take scan it and send it to you that also. Okay, is that clear? So you can start practicing with that also. What type of question they have asked, we'll come to know. Now, temperature. So as the area increases, resistance decreases. Temperature. So what happens? Temperature is dependent. RT is equal to what? R naught into 1 plus alpha T minus T naught. This is the formula. Here, R naught is the resistance at temperature T0, and RT is the resistance at temperature T. And alpha is what you call? Alpha is the coefficient of resistance. Okay, temperature coefficient of the resistance. Nature of the material means, example, like we have tungsten, nichrome. Okay, tungsten, nichrome. These are the wires which have very high resistance. Okay, these are the wires which are having very high resistance. Now, what is the reason why when the length increases, resistance also increases? What is the reason behind it? Example is, like suppose as the length increases, we are saying that this is L1 and this is L2. Okay, this is R2 and this is R1. So R2 is greater than R1, L2 is greater than L1. Okay, L2 is greater than N1. Now what happens when the electrons are moving, as the length increases, the collision between the atoms and the electrons when they're flowing, they collide with the atoms which are present in its path. So more the length, more will be the collisions and more will be the resistance. Understood? Is that clear? As the length increases, I'm saying that as the length increases, resistance increases. What is the reason behind it? Means as the length increases, there are more atoms in the path of the electron, and there will be more collisions. More collisions gives rise to more resistance. Understood? That is the reason behind it. Second one, area. A simple example. You might have seen Emirates Road, like we have around 6 lanes around. Is it not? If you go to Sharjah, Dubai Road, there are only 2 lanes, 2 or 3, hardly 3 lanes. Okay, so less number of lanes, the speed is also less. Yeah, generally whenever there is 2 lanes or 3 lanes, speed is max 60 or 80. But if it is on the Emirates Road, is 120. Is it not? So more number of lanes, speed is also more, and more vehicles can pass through in 1 second. So same thing, as the area increases, there are more paths for the electron to flow. As the area increases, generally the electrons will flow on the surface area. They don't go from inside. More the surface area, more will be the electrons. More will be electrons to pass. There will be more paths and more electrons can flow through. That is about area. Is that clear, all of you?
Yes, sir.
There will be more. And one more thing. Then you might ask, there may be a question. Like suppose example. Generally, if you take, we don't have a thick wire, means we don't have, like area means we don't have only one thick wire. Generally, when you sleeve out a wire, there will be so many thin wires. Have you seen any time? If you sleeve out, suppose if this is a wire, there will be so many thin wires. Have you seen this one? Remove the sleeve of a wire. So many wires will be. Is it? Okay. Earlier, what happened? If you go to if anyone is from Karnataka, Mysore, and all, they know about it. In Mysore Palace, when I visited Mysore Palace, physics people only. They think about electricity again. When I visited that Mysore Palace is the only one palace which in the beginning, in 19th century, it was the first palace which has electricity. There's a wiring still. I think Dhruti, you know about it, right? Mysore Palace.
Yes, sir, I've been there.
You visited? Did you see electrical wires over there?
Sir, I was young. I didn't notice all that.
You didn't know about that. People like me, okay, we are physics people, so we search for physics only everywhere. So what happened is I saw the lamps. Then when I saw lamps, then I thought there should be some electrical wires also. Then I saw the wires also. Then that was a first, when I inquired about it, then I came to know that was the first palace which had electricity with DC. All the lamps work upon DC current. So there was a DC generator also. Okay. So at that time, the Wadiar family that was ruled by Wadiar. So that family, they brought the electricity from somewhere, some country. The same thing is there in Hyderabad, in Nizam. Nizam was ruling at that time. The same thing. Even you can't imagine at that time we used to have. There used to be 1 paisa coin or 2 paisa coin at that time. There is, you have a box, like in India, we have like, if you want to make a local call, just put 1 rupee coin and then you can talk. Is it not? Do you know this one?
Yes, sir.
This is something like local calling or something. So same thing. Suppose if you want 1 bucket of water, hot water, just put 1 paisa coin at that time. I'm speaking about 1945 or 1940. Just put 1 paisa coin in that, then you will get 1 bucket water, hot water. Can you imagine like that? So these were the technology which we used to have before. So okay, come back to the thing. So here my meaning is like the thing is here. It's not like a thick wire. Instead of using a thick wire, we use so many thin wire. In the olden days, we used to have a thick wire. The problem with the thick wire is, if suppose while folding, if the wire breaks, then what happens? The whole connection is gone. Then either they have to check every point where the wire is broken, and they have to again change the wire. For that reason, they brought this type of wires. And the advantage of these wires is what this here heating effect is more. Here heating effect is more. There are 2 disadvantages. One is heating effect is more. The second is what? While folding, if it breaks, then there's a loose connection. That's a problem. But in this type of wires, even if one is broken, no problem. Current still can flow. And there is more the wires, more will be the surface area, right? Everyone has a surface area. Like there are 10 wires, example, if there are 10 small thin wires, 10 thin wires have surface area. Is it not? When you add that surface to 10 wires, that will be greater than this thick wire. Got it?
Yes, sir.
Is that clear? So that is
Yes,
how
sir.
the area is explained. Okay. Now come to temperature. What happens here? RT is equal to R0 1 plus alpha T minus T0. R0 is the resistance at temperature T0 and RT is the resistance at temperature T. Clear? And last one is what? Nature. Nature is what? That is tungsten nichrome wire. These have very high resistance. That is the reason why tungsten wire is used in in the lamps, and nichrome wire is used in heating filaments. Okay, especially in heating stoves and all. They use this one. Okay, is it clear, all of you?
Yes,
Is it clear?
sir.
Yeah. So all are online today. No one is on site today. Nice. So Aran also shifted to online. Okay, is it clear, all of you? Can I go to the next point now? Conductivity, resistivity.
Yes, sir.
Yeah, okay. So did you copy this or not? Just take a screenshot, then we can go ahead.
Sir, I copied.
Oh, very good. Thank you. Thank you so much. Appreciate.
Sir.
Okay. Okay. I need to see how many notebooks you completed by the end of the year.
Nothing. 0.
Ah.
0 it is, okay.
Now, next one is we have resistivity. Okay, so we know that R is proportional to L and R is proportional to 1 by A. Okay, so this is equation number 1 and this is equation number 2. So R is proportional to what? L by A. To remove this proportionality constant, I am writing R is equal to what? Rho into L by A. So implies what? Implies rho is equal to R into A by A. And what is the unit of this? Unit is ohm meter. Okay, unit is ohm meter. Once again, as the length increases, resistance increases. As the area increases, resistance decreases. Put it together, we will get this one. Remove the proportionality constant, we get rho, and then cross multiply it, we get this. Okay, the definition for this is what? Resistance of a wire. Resistance of a wire of unit area per unit length. Of unit area per unit length. Okay, this is about
The resistance of a specific wire, right?
yeah, of any wire. If you take a wire, it's unit area per unit length. Okay.
Okay, sir.
Now, next one is what? Conductivity. Next definition. So resistivity is here. Resistivity is denoted by rho. Resistivity is denoted by rho, and it is measured in what? Unit is ohm meter. Next is conductivity. Conductivity is what? Conductivity is sigma. Reciprocal of resistivity. Reciprocal of resistivity is conductivity. So conductivity sigma is equal to 1 by rho. Units of this is what? There are 3 units: Siemens per meter, or ohm per meter, or mho per meter, MHO, mho per meter. This is the unit of conductivity. These are the 3 units. Next comes, okay, our conductivity's physical meaning is what? It is a property of the material which allows the current to pass through. It is a property of the material which allows a current to pass through. That is the definition, physical definition, or the physical meaning of conductivity. Now, or if we come to physical meaning of resistivity, it is a property of the material which resists the flow of current. Okay, this is the definition I wrote. Okay, this is a mathematical definition. But physical meaning is of resistivity is it is a property of the material which resists the flow of current, and this is the property of the material which allows the flow of current. Now, next one is we have drift velocity. Okay, so we will go to the drift velocity, then yeah. Then before that we have current density. Okay, we'll define current density, then drift velocity. Current density is what? J. Current density is J. So what is current density? Current per unit area. Okay, current per unit area is current density. So J is equal to what? I by A. The unit of this is what? Ampere per meter square. Okay, unit of this is what? Unit of this is ampere per meter square. That is current density, J. Okay, so we have some relation between current density and drift, the other resistivity and conductivity. That also we will see simultaneously. So we can finish it off that part also. So then we have to discuss about the drawbacks. Once I'm done with drift velocity, I'll be going with the drawbacks of Ohm's law. Then I'll be discussing about the graphs. There are a few graphs I need to discuss about that. Then, so current density here. One second. Yeah, current density is what here. So we have a relation here. What is that? V is equal to ED. Okay, we have yeah, there are 2 formulas here. V is equal to ED. V is equal to E into D. So we are writing here V is equal to E into L. L is the length of the wire here. L is the length of the wire. Now come back to the Ohm's law. We have V is equal to IR. But what is R? R is equal to, here it is given. R is equal to rho into L by A. Is it clear, all of you? Is this clear? See, we have V is equal to ED. I have taken in the place of D, I have taken length. Why length? Because now electron is not flowing only from one place to another place in the wire, from one end to another end. 1 second. One end to another second. One end to another end in 1 second. How much distance it is traveling? So that is why I'm saying length. Now V is equal to IR. R came from here. Rho into L by A. Now equate both of them, equation 1 and equation 2. So what will happen now? E into L is equal to what? I rho L by A. Okay, this and this will go away. Is that clear, all of you? Is this clear, all of you?
Yes, sir.
Yes, sir.
Then what is I by A now? I by A means? I by A means current
G.
density. J
Current
is current density. So E is equal to what? J rho. This is the first derivation. E is equal to J rho. Now E is equal to 0. Now also we have what is sigma? Sigma is equal to 1 by rho. Now substitute back again into the equation. It will become J by sigma. So that will become J is equal to what? E into sigma. Clear? J is equal to E into sigma. Is that clear? Once again, current density is current per unit area. V is equal to ED or V is equal to EL. V is equal to IR. So R is equal to rho into L by A. Now L and L will go away. Then we get E is equal to J rho, and sigma is equal to 1 by rho. E is equal to sigma by rho, or J is equal to E rho. That is a formula for current density. Relation. Okay, 2 relations we got it. Is it clear, all of you?
Yes, sir.
Yes, sir.
Now going to mobility, but because mobility has drift velocity, so I don't want to discuss that. First, let me finish up drift velocity, then I will come back to this one. Or before that, I have ohmic and non-ohmic conductors. So ohmic and non-ohmic conductors. Ohmic conductors. What do you mean by ohmic conductors? Anyone?
Conductors that follow the law of Ohms, that follow Ohm's law.
Very good, very good. The material which obey Ohm's law. Okay, the material which obey Ohm's law, is known as ohmic conductor. So if you draw the curve for ohmic conductor, it will be like the straight line. This is a voltage and current. Voltage and current, it will be a straight line. Ohmic conductors will have a straight line. Example for this is what? Copper. All the like copper, silver, gold. Okay, these are the material which have ohmic conductor, which obey the Ohm's law. Non-ohmic conductors. What are non-ohmic conductors?
Which do not obey
Which do not obey Ohm's
Very
law.
good. Which do not obey Ohm's law. Okay. Material which do not obey Ohm's law. Which do not obey Ohm's law. Okay. Ohm's law is known as non-ohmic conductor. So if you draw the graph like this, it will be maybe something like this. Okay. Or it may be something like this. So this is voltage versus current. Voltage versus. Please do write the units. Whenever you're drawing a graph, please do write the units. I didn't write the units here. Voltage should be measured in volts. Current should be measured in amperes or milliamperes or microamperes, whatever it is. Please do write the units. If you don't write the units, you'll lose the marks. I'm telling you. Whenever you draw a graph, especially in physics or chemistry, whenever you draw a graph, label it properly and give the units for that. Okay. If you don't give the units, half mark they will cut. If you don't write the parameters,
What units?
no?
Like what units and where
Yeah,
should
here
we?
it is in amperes, right? Here it is in volt. Potential difference is measured in volts, right? It is measured in volts. Here it is in amperes. Here it is in volts. Is it not? Potential
Yes, sir.
difference is measured in volts. Is it not? So that is what you have to write. Okay. Please copy this quickly. Then we'll go ahead.
Done.
Okay. Now, next one. So, drawbacks of Ohm's law is there. Okay. Can I erase this now? All of you, are you done?
Sir, 1 minute.
Okay. Any doubt in this? Please tell me.
No, sir.
Done, sir.
My pace is little faster. I'm telling you. If you don't understand anytime, just please stop me and ask me, or you can write in the chat box. If you're not able to talk to me, just write in the chat box. I don't want like just I'm going faster and no one is following me. Okay, clear?
Yes, sir.
Okay, because the
Yes,
fourth
sir.
chapter is lengthy. Why I'm telling you, because fourth chapter is moving charge magnetism. There are around 10 derivations in that lesson, and it's very conceptual also. A very important lesson also. Okay, magnetism and matter is not that much. It's a small lesson. It can be completed in one lecture. Okay, small lesson. Only definitions are there, and they have removed in that also some part is deleted also. So that won't take much time. But fourth lesson will take more time. Clear? And it is important also because you have Biot-Savart law, ampere circuit law, many laws are there in that. Okay. Now, can I go ahead now? Can I erase this?
Yes, sir.
Okay. Now,
Yes, sir.
now, and the drawbacks of Ohm's law or limitations of Ohm's law. This came for 3 marker in 19th March boards. Sorry, 2020 March. Okay, board paper. So limitation 3. It came for 3 marker. Limitations of Ohm's law. Limitations of Ohm's law. Okay. What is the first limitation? So the first limitation is V ceases to be proportional to I. V ceases to be proportional to I. This is the first one. Okay. The second law means what? Here means the graph is not straight line. It's like this. Okay. That is, this is current and this is voltage. If you draw this, Current is measured in amperes and voltage is measured in volts. So it's not a straight line. If it is a Ohm's law, it should be a straight line, but it's not a straight line. Understood? So this is the first drawback. Generally for
Yes, sir.
non-ohmic material like tungsten, molybdenum, or chromium, nichrome, such type of parts, it's not possible. Second one is like, suppose if you are taking a diode, okay, like if you take a semiconductor diode or PN junction diode. If you take a PN junction diode, in PN junction diode, what will happen is, suppose if you draw a graph like this. So this is forward bias. This is forward bias. Forward bias is voltage versus current. All of you are there or sleeping?
There, sir.
Here,
Yes,
sir.
sir. Listening, sir.
Aaron, are you sleeping or are there?
Sir, he is sleeping.
I don't know. He's not answering also. Okay. Now,
I told you, sir, he's sleeping.
current is in microamperes. Okay. So what happens here? If you draw this, it is coming like this. Okay. The graph comes like this. See? So actually forward bias and reverse bias, only we just change the polarity. We just change the polarity. If you look at the diode, example, this we did in the last chapter. Okay. So suppose if you see the battery, this is P is connected to positive and N is connected to negative, and this is a voltmeter. Okay, this is a voltmeter. Here we take a ammeter also here. This is what milliammeter. This is for this is for forward bias. For reverse bias, how it is? The same thing, but just what we do is this is a voltmeter and it is connected to negative like this. Microamperes, the negative, only the polarity is changed. But by changing the polarity, only graph should be same, but should be in the negative region. But it is not the same. What happened? It should have been like this, right? It should have been come like this, but it is in a different the pattern is different. So this is also one of the drawback of Ohm's law. Third drawback. The third drawback is what? Like if you take gallium arsenide diode, or we also known as a tunnel diode. Known as tunnel diode. In tunnel diode, what will happen? You know, if you draw the characteristic, if you draw the graph, it is something like this. Means what? If you draw for three different voltages, current is same. For three different, see, for this voltage, for this voltage, for this voltage, current is same. What is the meaning of this? Means actually, as per the Ohm's law, every voltage should have a unique current. Is that clear? Every voltage should have a unique current, but it is not. See, for V1 current is same, V2 current is same, V3 for three different voltages. For three different voltages, current is same. So such type of phenomena. So this is also one of the drawback of gallium arsenide diode or tunnel diode. Is that clear? Is it clear?
Yes,
These are
sir.
the three drawbacks of the Ohm's law. Clear? So now, if you look at the resistivity, temperature resistivity, there is one more situation. As I wrote here, RT is equal to, you can write like this also. R2 is equal to R1 into 1 plus alpha T2 minus T1. This also we can write. It's same. For resistivity, ρ2 is equal to ρ1 into 1 plus alpha T2 minus T1. Same formula. This is for resistivity. This is for resistance and this is for resistivity. Ρ2 is equal to ρ1 into 1 plus alpha T2 minus T1. Now, there are certain graphs here. One for copper. For copper, if you look at this